load balancers. So we are looking at load balancers now. So if you go into the portal, so right now in Azure, these are the 4 load balancing services. We have the application gateway, you have the front door. Remember, we're talking about front door at the first class. So this is where front door comes in. There's a front door for content delivery network. There's a load balancer, the Azure load balancer, and then there's the traffic manager. Okay, so I'm going to give us a brief overview of these solutions. Right. Check. So we have 4 solutions. Since there are 4, we can put them in cardinal groups. 8 minutes. Okay. So when we talk about load balancers, we can have load balancer, Azure load balancers. Then there is the traffic manager. Is another form of load balancer manager. And then there is the app gateway. Okay. Then there's also the Azure front door for content delivery. Okay, so these are the different offerings for load balancers. Azure load balancer is a regional service. Give me a moment. Excuse me. Yeah. So the Azure load balancer is a regional service. The application gateway is also a regional service. Traffic manager, okay, and Azure front door are multi-region. They can cut across multiple locations, multiple regions. But with load balancer, with the application gateway, they are regional services. So, what in the OSI layer, where do you think Azure Load Balancer would belong? So, what layer will be Azure Load Balancer? What layer will be App Gateway?
That'll be layer 4, I'm guessing.
Why?
So that is for transport.
What of Application Gateway?
Layer 7,
Why?
application layer.
You know this thing. You come and be teaching the class.
No, I don't know. I'm just imagining it.
Yeah. So, are we familiar with the OSI layer? Let me see if I can bring that up. OSI layer model. You might be asked these questions in uh, your interviews. Okay. So this is where you have the copyright scheme. Go to sites. Visit sites. So this is a typical OSI. Okay. So transport layer. This is see. Okay, it's not cooperative. So this is the transport layer. The transport layer belongs to Azure Load Balancer. The application layer belongs to App Gateway, Application Gateway. The reason why the transport layer is layer 4 is because is a non-HTTPS transaction. Okay, and the application layer has HTTPS transaction integrated in it. So Azure Load Balancer is HTTP. Okay, application gateway is it gives us the ability to use HTTP and also HTTPS protocol. Okay, so we can use we can transfer resources using any means with application gateway. And another benefit of application gateway is that uh, it has its own inbuilt firewall. Okay, so that's another reason why it is a layer 7 load balancer. It has its own web application firewall. Okay, so try to pull up information on the differences between Azure Load Balancer and Application Gateway.
Quick question, sir.
Yes, sir.
I think layer 4. You said Azure Load Balancer uses HTTP.
Yes.
I, I'm not sure. I thought UDP and TCP is what that operates at layer 4. As a
Well,
protocol.
this is Azure. You know, I told you that.
Okay. Oh.
This is our Azure. In our own house, this is how we run. That's what Azure is telling you. We are not
Okay.
using TCP right now. We are talking about load balancers and that Azure Load Balancer is internal. We are going to have backend pools. Your backend pool going to be internally located. Okay. So for you to be able to access the backend pools, you have to distribute the traffic using the Azure Load Balancer. For App Gateway, it's going to be sitting in front of the network since it has a dedicated firewall. Okay, so traffic coming from the public, we have to pass through the firewall. The load balancer in the App Gateway will distribute the traffic to the backend pool. So just have an understanding. Layer 4, Azure Load Balancer, Application Gateway, and Azure Load Balancer supports internal traffic load management. Okay, it's not exposed to the public. And then there is the App Gateway, which has its own dedicated firewall that we can use to secure our application. So for Application Gateway, this is where we integrate security into our web applications, app services. Okay. Let's see. Let me see if I'm not missing anything. Okay. All right, so that's all for now. There's a lot that goes into load balancing, but this is an introduction. It gives you an introductory understanding of how load balancing works in Azure. Let's go back into the notes. We'll continue from here. Well, let me see if I can close this up for load balancers. The treatment slopes. Okay. Azure load balancer. Okay. So this Azure load balancer. So now with Azure load balancer, it's going to be internal. The load balancer will sit between the front end and the backend pool. Your backend pool can either be a collection of virtual machines or virtual machine skill sets or app services. Okay, all this can be examples of the servers we can have in the backend pool. So your Azure load balancer can either be public or private. Just know that load balancers are used to route traffic to the backend. Okay, so your backend consists of a backend pool. It's available on HTTP. Okay, so HTTP is port 80, and this traffic is going to be routed using the HTTP port to the backend pool. So we have a web tier subnet where we have the backend pool in this case. This web page is running on port 80. Okay, maybe a classical solution, internal web applications that we are managing, internal web pages that are not exposed to the public. So we can use Azure Load Balancer to route traffic, manage requests into those environments. Each resource has its own dedicated IP portal address, portal number. For SQL servers, their port number is 1433. So you're going to use the port number for the SQL server to route traffic. Remember, your backend pool can either be a VM, SQL server, uh, VM skill sets, virtual machine skill sets, or app services. The addresses are never exposed directly to the internet. Okay, so internal resources, internal applications that run in Azure or on premises will be a good use case for integrating Azure load balancers. Okay, so this is a use case. We can use the internal load balancer to receive requests from the databases, okay, so that it can distribute traffic to the backend SQL servers, which are databases. Is usually limited to the internal network. Skills vary. It can either be standard, basic, or gateway skill. Okay. So with a basic skill, we have up to 300 instances. The standard skill gives up to 1,000. But in a typical environment, you want to be managing 500 instances. So it depends on your needs. If you are the more instances you have in your backend pools, the more resources you will need to manage patching, security, updates of those instances, okay, configuration of those instances. So you have to factor in the overhead cost of managing your backend pool. The basic also provide HTTP, but just HTTP and TCP. But with standard skill, of course, additional benefit is being able to integrate with the public over HTTPS ports. The standard skill is zone redundant. It can operate across zones, availability zones in Azure. Okay, so that's that for load balancers. We're gonna continue from here. So other offerings are the application gateway. So the application gateway has its own inbuilt firewall. Of course, we also have backend pools. But in this case, your backend pools are virtual machines, virtual machine skill sets, servers. Okay, and you're going to have some rules created on how we're going to be routing traffic to the backend pools. You're going to determine the listening port. You want it to be listening on port 80 or port 443. You're going to create that listening port, and then your app gateway is going to secure access to the backend pool using the rules we have put in place. So the web application firewall integrated into the app gateway protects against threats and malicious activities identified by the OWASP top 10 recommendations. Okay, so if you want to check out OWASP top 10, so every year they release some threats that customers need to be familiar with. So you need a web application firewall to protect your applications, and some threats that your applications could suffer are listed here: broken access control, cryptographic failures, injections, SQL injections, okay, security misconfiguration. All right. So these are the threats and vulnerabilities that the web application firewall is built to guard your apps against. All right. It also has, yeah, it's secure. So it comes with its end-to-end encryption functionality. You can either route using path-based routing or multiple site routing. With path-based routing, you can just route directly to the specific backend pool. So there is an image backend pool and there's a video backend pool in this case. But for you to access the image backend pool, you still have to go through the same environment. So contoso.com/images, contoso.com/videos. In the case of multiple sites, that means we can have multiple websites. Okay, you can route traffic from multiple websites to their respective backend pools. So instead of going to the image through contoso.com, I can have a dedicated website for image and videos. Okay, so everything, my images are in their dedicated backend pool. My images are in their dedicated backend pool. Remember, the application gateway has its own dedicated firewall and load balancer. It's a regional service. Remember, the app gateway is a regional service. We can configure error pages. Okay, this is where error 404, page not found. What other codes? I think 500. Many times I've been asked those questions in interviews. Error pages 404, 400, 500. You can check out the different error pages. Okay, so you can also customize your error pages. So when we are configuring the app gateway, we get to set all this up. So this is a typical layout for configuring an app gateway. There's going to be a front end IP address. You're going to determine the port. Okay, you're going to determine where the listener port is going to be, whether port 80, port 443. And then we need a certificate. Remember, it has its own firewall. So for encryption, we will need a certificate also for the listener. And then we're going to configure rules on how we want to manage traffic in and out of the backend pool. Okay. Any question?
Maybe when we watch the video.
All right, let's answer this question together. Okay, no worries. Let's answer these three questions together. Put your options, your answers in the chat. Which criteria does application gateway use to route requests to a web server? Is it a host name? Is it a port? Type your answer in the chat. Okay, majority go for A. Number two, which load balancing strategy does the app gateway implement? Final answer? Round robin? Is that the final answer? Okay. Number three, the web team is installing the application gateway. They want to ensure incoming requests are checked for common security threats like cross sites to address the concerns. What should be done? Final answer? Just make an attempt, unless the people here are running. Just make an attempt. Okay. Yeah, can you see? We got it all. The application gateway uses the host name, the port, and the URL path. The app gateway distributes requests using round robin. Okay. So this is where we're going to stop today. Please try to complete the labs. Complete the labs before Tuesday. Tuesday is let me see.